Hi friends, in this video we are going to learn about find the non-singular matrix P and Q such that PAQ is in the normal form. So where A is equal to this. So I don't have space, that's why here I am writing this matrix, same matrix here. So after that I will solve this problem from here. So I want to convert. I want to find the non-singular matrices P and Q such that the product of PAQ is in the normal form. Means this P, after finding this P, this A and Q is in the normal form. That is, either this is in the form of IR 0 0 or this form or this form or here. So the concept is, this is given A, this matrix is given 1 0, this is the 3 cross 3 matrix. So try to find the non-singular matrices P and Q such that this PAQ is in the normal form. So either that product of this PAQ in either this one of the form. So how to find this P and Q with the help of this matrix is the following. So I will write here. So I will write here A as, I will rub this, I don't have space, so I will start writing this here. So just write A is equal to I, A and I. So this matrix is of order 3 cross 3. So here take the identity matrix of order 3 and this is the identity matrix of order 3 cross 3. If at all, for example, if you have matrix A of order, let's say 4 cross 3, at that time you have to take here, write A as, here take identity matrix of order 4 cross 4 here and A same as here, and take identity matrix of order 3 cross 3 from right side. If at all, for example, if you have A of order, let's say here I am writing 5 cross 4. At that time, write this A as here. This is for the A equal to identity matrix of order 5 cross 5, and this is simply A, and here identity matrix of order 4 cross 4. In our example, A is a matrix of order 3 cross 3. Here A is a matrix of order 3 cross 3. At that time here A is a matrix of order 3 cross 3. Here I am writing A is equal to I3 A I3. So means this you can write order of this matrix from left side. This is 4 5. Here I will explain. This is a matrix of order 4 cross 3. So if this matrix multiplication is feasible if and only the outer dimension of this matrix is same as the inner dimension of this matrix. So I have to take the identity matrix of order 4 cross 4 here. So this is the 4 cross 3 matrix. If the matrix multiplication of these two is feasible if and only the outer dimension of this A is same as the inner dimension of this matrix. So this is 3, so this should be 3. So this is the identity, of course. If this is 3, that should be 3, and if this is the 4, that should be 4. This is the identity matrix of order 4 cross 4, and this is the identity matrix of order 3 cross 3. So but in our case we have here A is a matrix of order 3 cross 3. Here I am taking this. Right here I am writing A is equal to I3 A I3. So now the process is, we have to find the matrix non-singular matrices P A Q such that is in the form of, let's say here I am writing I normal form. So here can I write? So try to convert this matrix into the normal form. So after applying elementary operations and after some stage, for example at this stage, let's say this is my A dash, and let's say this is my I3, and here let's say here P, and this is A, same matrix, and this I3 is, let's say, Q. So after applying the sequence of elementary operation, for example at this stage I get the matrix A dash is in the normal form, at that time whatever the matrix here, this matrix come, this is my matrix P and this is my matrix Q. So keep one thing in your mind. So whenever you are applying elementary row operation while converting this matrix into the normal form, at that time try to change in this matrix and this matrix remains same. Whenever you are applying elementary column operation to convert while converting the given matrix into the normal form, at that time make changes in this matrix and this matrix remains same. So I will explain with the help of here, for example, wait. So this is the given, let's say A is equal to I3 A I3. So here in my first step, for example, in my first step here I am applying elementary, let's say, row operations. So after applying elementary row operation, let's say this matrix A becomes, here I am writing A1 and this is equal to, at that here I am writing elementary row operation to this matrix, so this A becomes A1 and at that time here this A and I3 remains same. So I want to change, we have to change in this matrix I3, let's say here I am taking 1. So this A1 matrix is obtained from A by elementary row operations and this I3 matrix obtained from this I3 by elementary row, this row operations, and this A as it is and this I3 is also as it is. Now in the second step, for example, this is my second step of the elementary row operation. Now wait. So if at all, if for example, if at this stage, if in my first step of elementary operation, if this matrix is in the normal form, here I am saying if this A1 is in the normal form, at that time this is my P and this is my Q. If at all, if this is not, if this A1 is not in the not in the normal form, so again we have to apply elementary operation. So for example, this is my second step of elementary operations. Again here I am applying, let's say, elementary row operation for the sake of understanding. For example, here again we are applying elementary row operation to this A1 to convert into the sum form. For example, here A1, let's say A1 is converted into A2, let's say, and here I3 is converted into, here this I1 is converted into, let's say, I2, and this A and this I3 remains same because we are applying elementary row operations. So whatever the change we have to do in this matrix, left side of A. So here now this is the, let's say this A2 is equivalent to this A1 obtained, this A2 is obtained from A1 by elementary row operations. So now at this stage, if at all this A2 is in the normal form, so if at all this A2 is in the normal form, at that time this is my P and this is my Q. This is my P and this is my Q. If A2 is in the normal form. If A2 is not in the normal form, again we have to apply the elementary operations. So for example, at this time, here let's say here I am applying the elementary column operation. So after applying elementary column operation to this A2, let's say here this A2 becomes A3. Let's say this A3 becomes A2 becomes A3 and this I3 to remain same. Here I am applying elementary column operation, so this is same. Now whatever the change happen in this identity matrix. So here I3 A2 as it is, and this is A and this is I3. Let's say here I am taking I3 and this is, let's say here I am taking here I am writing this as, here this is I1. This is I3 as I1. So this is I3 as I1. So here I am writing left side of, at the top I1, I2, I3, and from right side here I am writing 1, 2 at bottom. So now if at this stage, if A3 is in the normal form, so this, if A3 is in the normal form, then this is my P and this is my Q. If not, so if not, again I have to apply the elementary column operation. So let's say elementary either column operation or row operation. So for example, here I am applying again elementary, let's say row operation only. So at this time, this is my, let's say, A4 and this is, here I am applying elementary row operation. So this is I3 and this is third. The I2 becomes I3 and this is A and this is I1. So this I1 is same as this. Why? This we are applying elementary row operation. If at all, if this A4 is in the normal form, this is my P and this is my Q. That is the procedure. So I will solve this problem with the help of this technique. So this thing is important. Why? So write matrix A is equal to I and A and I. So if at all here. So here first write this matrix. Here I will run this. First write. So for example, this is a matrix of order, let's say M cross N. So first write I, A and I. So this is M cross N matrix. So take identity matrix of order here M cross M and take identity matrix of order here N cross N. So this is M cross M. So for example, this is M. This matrix is identity matrix of order M cross M, and this is the identity matrix of order N cross N. N cross N. So here I will solve this example. So here I am writing A equal to I, A, I. Here 3, 3. Because A is a matrix of order 3 cross 3. So here is the identity matrix of order 3 cross 3, and here is also identity matrix of order 3 cross 3. So now given A is, here I am writing A 1, 0, minus 2, 2, 3, minus 4, 3, 3, minus 6. Now take here is the identity matrix of order 3 cross 3. 1, 0, 0, 0, 1, 0, 0, 0, 1. Now A as it is. Now here is also identity matrix 1, 0, 0, 0, 1, 0, 0, 0, 1. Now so this is the matrix. I want to convert this matrix into the normal form. So here first I am applying the elementary column operation as, can I apply here C3 changes as minus 1 by 2 to C3. Here I am multiplying the column C3 by minus 1 by 2. Just here I am multiplying the column C3 by minus 1 by 2. Then I get the resultant matrix as here 1, 2, 3, 0, 3, 3, and this is minus 1 by 2 into minus 2, 1. This is simply 2, and this is, let's say, 3. Here equal to, in this step here I am applying elementary column operation. So this matrix is as it is 1, 0, 0, 0, 1, 0, 0, 0, 1, and this is as it is. Here I am applying elementary column operation. So this whatever the changes occur in this matrix. So now can I write this? First column as it is 1, 0, 0, second column 0, 1, 0, third column 0, 0, minus 1 by 2. Now again I am applying the elementary column operation as C3 changes to C3 minus, let's say, C1. Here this 1 minus 1 0, 2 minus 2 0, this 3 minus 3 0. Then I get the resultant matrix here as first column as it is 1, 2, this is 3, second column 0, 3, 3, this is 1 minus 1 0, 2 minus 2 0, 3 minus 3 0. Now tell me, again this matrix is as it is. Here I am applying elementary column operation. So whatever the changes occur here. So 1, 0, 0, 0, 1, 0, 0, 0, 1. Now tell me the second step here. A, here first column is as it is. Here 1, 0, 0, 0, 1, 0. Now here C3 minus C1. 0 minus 1 minus 1. 0 minus 0 0. Minus 1 by 2 minus 0 minus 1 by 2. Now I want to perform here I want to convert this 2 and 3 as 0. So here I will apply elementary row operation as R2 changes to R2 minus 2 times R1 and R3 changes to here R3 minus 3 times R1. So here I will copy this. Now tell me the resultant matrix here. I will write here 1, first row as it is 1 0 0. My second row 2 minus 2 times 1 0, 3 minus 3, 0 minus 0 minus 0 0. Here 3 minus 3 times 1 0, 3 minus 0 3. Here 0 0 0. Now here I am applying elementary row operation. So at this time this matrix is as it is, and I have to make changes in this matrix. Here I will write this one as here. So this is 1. So I want to make change in this matrix. Now tell me the matrix here. This is the here first row is as it is 1 0 0. Now tell me the second row 0 minus 2 times R1, that is minus 2. Here is 1 and here 0 0. Now here tell me 0 minus 3 times 1, simply minus 3, and 0 minus 0 0, 1 minus 1 0 1. Now A is as it is. Now write this matrix as it is here 1. So 0 minus 1, and this is 0 1 0, and third row 0 0 and minus 1 by 2. Now come to here. Now can I change my C3 as 1 by 3 into C3? Here I am multiplying 1 by 3 to the entire column C2. Now I get the resultant matrix as here. This is my resultant matrix. I don't have proper space. Here I will. So here 1 0 0. So 0 1 1, and this is 0 0 0. Now which is equal to here as it is, write this matrix here 1 0 0 minus 2 1 0 minus 3 0 1, A matrix as it is, and write this matrix here 1 0 0. I am multiplying 1 by 3 to the column C2. So 0 1 by 3, and this is 0, this is minus 1 0 minus 1 by 2. Now come to here. Can I apply here elementary row operation as R3 changes to R3 minus R2, 1 minus 1 0. So here I get the resultant matrix as here I am writing 1 0 0. Second row as it is 0 1 0. Here 0 1 minus 1 0 0 minus 0 0, which is equal to, now this matrix is as it is. Make changes in this matrix. Here 1 0 0, first row as it is, and second row is also as it is, minus 2 1 0, third row. Here R3 minus R2, minus 3 plus 2, that is minus 1, 0 minus 1 minus 1, 1 minus 0 1. This is A, and this is 1 0 minus 1 0 1 by 3 0 0 0 minus 1 by 2. Now this matrix is converted into the normal form. So can I write this as, here I am making the block. This matrix is into the form of here I 2 0 0, and this is 0, which is equal to this matrix here 1 0 0 minus 2 1 0 minus 1 1 A, and here this is 1 0 minus 1 0 1 by 3 0 0 0 minus 1 by 2. Now this matrix is into normal form. Here this is my P, and this is my Q. So you can check these two matrices are non-singular, and this is my P and this is my Q. Thank you.